So, some additional useful things that you need to know. We talked about the gravitational force between two objects, g m1, m2 over r squared. So there is the force due to the gravitational pull. For each of the fields we're going to talk about, gravitational, electric, magnetic, we need to have a field strength expression. And here it is, this of course will be at a point. It is the force on 1 kilogram placed at that point in the field. So here we have force in newtons. This will be newtons per kilogram. So if you take F equals g m1 m2 over r squared, and you say, well, this is on the surface of the Earth, well, that's going to be mg, isn't it? m1g, let's say. So if we cancel that, and now we come to field strength, so this is F over m1, we've got newtons per kilogram over here, and this is g, this is meters per second squared. Are they the same? Well, let's just examine that and see what we think. So we have newtons per kilogram. Well, from F equals ma, newtons would be kilograms meters per second squared. And then we've got per kilogram. So that's per kilogram, kilogram meter per second squared. They are the same. So we have an expression then for gravitational field strength. G is big G, mass of the planet, over r squared. I suppose we could make that capital R. So field strength, generally Gm over r squared. The field strength around mass, m kilograms, a distance r from the centre of that mass, that is the gravitational field strength at that point. Now, previously we had F, of course that's a vector. This is F divided by a scalar. So this is also a vector. Of course you know that acceleration has direction, but just be aware that gravitational field strength, electric field strength, magnetic field strength, these are vectors. And around every field is made up of field lines. And we're going to come on and talk a little bit about that next.